Our Parker Solar Probe spacecraft will be the first mission to fly directly through the Sun's corona, the hazardous region of intense heat and solar radiation in the Sun's atmosphere that is visible during an eclipse. The extreme flybys, as close as about 3.8 million miles from the Sun's surface, will gather data to help revolutionize our understanding of the Sun and how it changes the space.
Of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
You may remember that NASA launched Parker Solar Probe on its journey to touch the Sun, so to speak, seen here in the early morning hours, August 12, 2018. The Solar Orbiter and Parker Solar Probe missions are complementary, focused on studying different elements of the Sun. They'll be sharing data, building a larger context with which to understand our star.
Venus, Solar Orbiter will help us understand how our star creates and controls the heliosphere, a giant bubble of charged particles blown by the solar wind that permeates the whole solar system and influences the planets within it.
A mere distance of 26 million miles away, the ideal distance to get a comprehensive view of the Sun and its surrounding atmosphere. It will fly close to the Sun every 6 months and endure temperatures more than 900 degrees Fahrenheit. To survive the intense radiation, a large titanium shield protects the instruments, while a carefully orchestrated dance of opening and closing eye holes in the shield allows the instruments to peep out at the right time. Other instruments will directly measure solar material from behind the shadow of the shield. All of these observations will tell us more about the Sun than we've ever known before. And by the end of the 7-year mission, we will have seen our star in a completely...
into very small portions of the Sun. Some of the instruments will be looking at the rim, or to make things more interesting, when one of the instruments detects a feature of interest, he will send automatically a trigger to the other instruments so that they can also change mode of operation and focus on that specific feature to learn more about it. And if that involves, for instance, the ejection of material,